Take a look again at the equations of lines. We're going to talk about point-slope form, slope y-intercept. Then we're going to talk about the equations if we're given the following: a slope and a point, a slope and a y-intercept, or 2 points. Given any of these three things, you can find the equation of a line. And then finally, we're going to talk about slopes of parallel and perpendicular lines. So point-slope form is your first equation. It's right here. What does x1 and y1 represent? What does x1 and y1 represent, Max?
Y is y and y1 would be.
Yeah. Where you see the subscript, it's a point. Let's write that down. And m is obviously, everybody? Slope. Okay, x1 and y1 is a point and m is the slope. So if you're given a point and a slope, all you gotta do is plug it in. That's it. So for example, let's take a quick look at saying the point is 2, 5, and the slope is, let's say point P is equal to 2, 5, and the slope is equal to 1/2. If I ask you for the equation of a line, given a point and a slope, you don't need to plug it into slope intercept. Use point slope. Use the one you see right here. Just plug it straight in. The 2 goes in for x1. The 5 goes in for y1. And the 1/2 goes in for m. And there's your equation. You don't need to solve for y. If you're going to graph this though, you want to actually see what it looks like, just add 5 over here. You could distribute the 1/2 and that's fine, but it doesn't need to be solved for y. That's a common misconception that many students have. And it's got to be in slope intercept form to answer. That's correct. That's right. And you can leave it like that. You can leave it like that. All right? If the problem says though, to give your answer in slope y-intercept form, then you should put it either y equals mx plus b form by distributing and moving the 5. We're going to do that in a moment too. Okay? Next, go ahead.
I learned another way to get the b.
Okay?
Where you're just plugging points. Just
Yep. And that, we're going to do that in a minute. Give it 1 second, we'll get to that, okay? You're talking about to get the b value for the y-intercept? Yeah, we'll get to that, I promise we will. So let's look at the next form. This is what we're going to see here. And this is called slope y-intercept form. Slope y-intercept form. Again, m is the slope. B is the y value of the y-intercept. What's the x value of the y-intercept? What's the x value of the y-intercept? 8? 0. Remember, when you want to find the y-intercept, you set x equal to 0, don't you? So b is the y value of the y-intercept. Let's make sure we specify that. Okay, b is the y value of the y-intercept. You could say that 0, b is actually the y-intercept itself. That's the y-intercept, 0, b. But b itself is just the y part of the y-intercept. It's this right here. So for something like this, you could be given a slope of, say, 8 and a y-intercept of 5. This is the easiest thing you will ever do. You get 8x plus 5. Okay? Now, we're going to do things that are much more difficult than that, so please don't think that that's what's going to be. This is the easiest version you could ever imagine. Given the slope, given the y-intercept, find the line. Oh, there it is. Not very tough. Okay, but we're going to do stuff that's much more difficult than that. All right, so let's jump right to example number 1. Now, I want you to read this for a second. I don't want you to jump to the answer right away, but just read it, please. So, are you given a slope here? Are you given slope? Are you actually given slope? Not can you find slope? Are you given slope? No. Can you find slope?
Yes.
Yes. I recommend starting every problem that you can find slope by finding the slope. So go ahead and find the slope. What do you got, Luke?
Is it 3 over -5?
Is he correct or is he incorrect? I'm seeing nodding, so I'm guessing yes. If we do this real quick, y2 minus y1. Well, if I call this coordinate number 1, then that's what it's going to be. Whoops. And I'll call this coordinate number 2, then it looks like this. If you need to do that, go ahead and do that, please. If you didn't get -3/5, you need to write x1, y1, x2, y2. Please do that, if it helps you. If I'm going to do y2 minus y1, I'll have 7 minus 4 over -3 minus 2. 7 minus 4 is indeed 3. -3 minus 2 is indeed -5. All right, that's good. So I've got, at this point in time, the slope and 2 points. 2 points. Which point should I probably work with? George?
2, 4.
Why?
Because it's 2 positive.
They're both positive. Life is easier when numbers are positive, right? You know that? It just makes it easier. Why not choose the easier route? So you've got a slope of 3/5 negative. You've got a point of 2, 4. Now, there are 3 ways that you could solve this problem at this point. 3 ways. 3 ways. Give me at least one of them for now. Give me one of them.
You could plug in the points into y equals mx plus b form and then plug in the slope as well. So
Yeah, so this is what Max was asking about earlier. You could start with y equals mx plus b form. You could plug in the slope. And then what you could do is you could take the coordinate 2, 4 and plug it in to solve for b. This is a method that not all your teachers show you, by the way. Believe it or not, this is something that I knew, but one of my teachers never showed me this. And when I saw it later, I was like, oh wow, let's see if we can find b. If you want to find b, just plug in 2, 4. 2 goes here, 4 goes here, and solve for b. So that's one way of getting this, but it would be in slope y-intercept form, which we then have to convert. So let's do that real quick. Max, your hand, I saw.
When I learned this, I just learned it as called the other way.
The other way?
Yeah.
Yeah, I mean, this is just slope y-intercept form by solving for b. It's not like any crazy method. It's just more of it's another technique. This becomes -6/5, right? So when I add 6/5 over, 6/5 is 1.2. I'm going to add that to 4, so b is 5.2. It's messy. So we'll get this as our answer. Now, can I leave my answer like that? Normally I'd say sure, if the problem said determine the equation in slope y-intercept form. But what kind of form did it ask for? Standard form. And standard form is really annoying. It's ax plus by equals c, isn't it? It's really annoying. So after we do this problem, you're going to realize that this was not the most direct way to do this because the answer needed to be in standard form. We'll show another 2 ways, and those are more direct. But let's prove it anyway that it is true. So let's continue with this idea. Same problem still. So let's make this into standard form. Move the x over. Okay, make sense of what I just wrote, please. How do I get rid of a -3/5 x on one side? How do I move it over? By making it positive. Remember, if you move an entire, God bless you, if you move an entire term from one side of the equation, such as this whole term, to the other, you always just switch the sign. It's always an easy way to remember, switch the sign. Now, I can't leave it in standard form like this, believe it or not. I can, because I don't care. But for some reason, I don't know why your books teach it this way, that A, B, and C need to be integer values. It really doesn't make a difference in life. Who cares? But if you want to get to be in integer value forms, 5.2. What is that going to be over 5? What's 5.2 as a fraction over 5? 5 and a fifth, right? And 5 and a fifth would be 26 over 5. Think about that, because 25 over 5 would be 5. So this is really 26 over 5. So multiply the whole equation by 5. Multiply the whole equation by 5. When I multiply 5 times 3/5, what happens to 5s?
cancel out.
Maybe 3. 5 times y is 5y. 5 times 26 over 5, those 5s cancel, leaving 26. Okay, now, how do I know I'm right? What's the slope? Slope is negative a over b, isn't it? Negative a over b. What would that make the slope? Negative 3 over 5. And look at that. That was what our slope was to start. It's not a coincidence the way this works. Okay, all the forms are interchangeable from one another.
Check your answer, you could also plug in 2 and 4.
Absolutely, or even better, the other point that we didn't even use. Remember there was another point with a negative coordinate? You can plug that in here and see that it's true, and that will prove also that your answer is correct. Now, if I were to be more efficient, I could go to another form. Instead of y equals mx plus b, I could use these two pieces of information, negative 3/5 and 2/4. All right, I could use my slope and my point, and I could use, instead of y equals mx plus b form, what could I do? With this point and this slope, what can I do instead? George?
You can modify it, like you can subtract 3 from the y and add 5 to the x.
And do what with that?
That makes it
Yeah, but we already have another point. Why would I want another point? I have a second point already. I could do two other things. I can go to point slope, which will also not be very efficient. I'll show you that. Or I can go right to standard form, actually, and explain that one. Let me go to point slope first. I want to prove to you that this is not a very efficient means either. It's better, though. It's better to do this than to do slope y-intercept if you're trying to get it into standard. Go ahead, Tristan, sorry.
Is point slope ever like the best option?
If you're given a point and a slope and it doesn't tell you to specify the type of equation at the end, then it's the best option. Whenever you're given a point and a slope, always go to this, unless the problem says determine the answer in slope-intercept form, or it says determine the answer in standard form. But if it doesn't tell you the specific way to determine the answer, do it this way. Because now all you got to do is plug in. Now the reason this is a little bit easier to work with than what we just had with y-intercept, with slope y-intercept, is because now I can multiply by 5 at this point to make it easier. Multiply both sides by 5. Please remember that when you multiply the right-hand side by 5, this is a triple multiplication. Once these 5s multiply, they're gone. Take a look up here, please. These are gone. Okay, those 5s, they cancel each other, leaving behind what's left there. Please do not distribute that 5 into that parentheses. Please do not. Okay, again, multiplication is commutative. So I can multiply these two first. This is exactly what I did, giving me this as an answer, and then this part just carries right down. As a result, I could say, okay, 5y minus 20 equals negative 3x plus 6. Move the 20 over, move the 3x over, and I get the same answer I just had. Exact same answer we had a moment ago. So we're good so far. It's in standard form. Obviously, x and y can be switched to make it really look in standard form. It doesn't matter, though, that way. The last way to do this is to jump right to standard form. To jump right into standard form. So let's do that. Negative 3/5, and the point is 2/4. So this is method number 3. If I want to go right to standard form, I start by writing standard form. What's A and what's B? What's A and what's B? You should be able to tell me right away. Right away, what's A and B?
Negative 5 and 3.
3 and 5. 5 and 3. Notice, look. Remember, slope is written as negative A over B, so A is just 3 and B is just 5. Remember that earlier we talked about the fact that in standard form, slope is negative A over B. Well, that means that 3 is A and 5 is B.
Oh, so you don't include the signs for that?
Well, because the negatives are in both spots here, Tristan, they don't actually occur, they don't matter. So A is taken the place of by 3, isn't it? And B's place is taken by 5. If this had been a positive here, then one of these had to be switched, yes. Okay? But now, look what I have. This looks very similar. Look how similar they are. This here is pretty much the same as this, except now there's 26 and there's a C. How do I get C? How do I get C, Max? Plug in the point. Plug in the 2, 4 right here, please. Go ahead and plug in the 2 comma 4 to this. And if c is 26, I can write my statement as 3x plus 5y equals 26. Again, all 3 methods give you the same answer. That was the point of this problem. All 3 methods give you the same answer. We're probably going to run out of time. Let me give you a quick direction as to what I want you to do. I think I have a couple more. Yeah. So those are the 3 forms we went through. We were talking last class about slope-intercept, point-slope, and standard. Those are the 3 forms we're concerned with. Okay? Slope-intercept, standard, and point-slope. Now, any of those forms of a line can be used at any given time. It depends on the context of the problem that really dictates which one you should use. If you're given a point and a slope, it makes sense to use point-slope. But if your answer needs to be in standard form, then maybe go write the standard form using the slope as negative a over b, and then you can figure out the value of c. But what we're going to do now is we're going to carry over or continue with that concept and talk about parallel and perpendicular lines. Now, you know the concept of slope already is the steepness of the line or the rate of change of the line. If a line is very steep, it has a slope that is highly positive. If it is not steep, it could have a slope that is around like a half or a third, near 0. We could also have negative slopes, and negative slopes fall. Steep negative slopes look like this. Slopes that are not steep, that are negative, might look like this, like negative 1/2 is a slope. This concept here, this idea of parallel and perpendicular lines applies to this because think about what a parallel line is, or what it's parallel to. A parallel line, parallel to another line, obviously, another surface, are 2 lines that never intersect. Right? We know that these 2 would intersect if they crossed. 2 lines that are parallel would go on forever and never intersect. What do you notice just by looking? What do you notice just by looking? These lines have the same what? Slope. Just by looking, just by inspection, the slopes are going to be identical. What's up?
So you can tell if it's parallel because the slope will be the same, the y-intercept will be different.
Well, the y-intercept is different. Very good. Nice haircut, by the way. The y-intercept is definitely different, right? The y-intercept might be like 5 in one location, or for one line, and it might be negative 3 for the other. Yet they still run alongside one another, and they never change the distance between the 2 lines. That's what parallel lines are, think about it. The gap between the lines is consistent. That's all it is. It's another way of thinking about a parallel line. The distance between the lines is always the same. That's how a parallel line can be defined. Because if the distance between the lines got closer and closer, what's going to happen to these lines eventually? They intersect, right? If the distance between them. But if the distance between them stays the same forever, they're always going to be parallel, aren't they? So another way of thinking about parallel lines is that gap between them being consistent the whole way. Knowing though the slopes are identical. George, did you have a question?
Yeah, I was just wondering, like, for number 2 it says m1 times m2 equals negative 1. And I was just wondering, like, could it, like, why does it have to be negative 1? Like, what if there's, like, does it differentiate if there's, like, a negative slope or a positive slope?
Well, tell me something real quick. Parallel lines. Give me an example of your arm. Show me with your hand like a positive line. What would it look like? Positive slope, positive slope. Yeah, it would go up like that, right? And what would a negative slope look like? And wouldn't those be good examples of perpendicular lines? So lines that are perpendicular, if one of the slopes is positive, what should the other one automatically be?
Positive, but like what I'm saying is like not like if it's like this, but like if they're both like this or if they're both like this, why are they like equal or negative?
It wouldn't. You're mixing up parallel and perpendicular, George.
Oh, yeah.
Parallel lines is first statement. They're always equal to each other. Perpendicular is what I'm talking about for number 2.
Yeah.
Okay? So for number 2, the second statement is talking about lines that are perpendicular. And the easy example to think about, easiest example of all, a slope of 1 and a slope of negative 1. If you graph them on a calculator, now on your calculator it's tough to see this because the screens are not the same. They're not, like pull your calculator up, right? Look at your screen. It totally screws people up. And I'll explain what I'm saying here. Yeah, let me see. Let me see the screens. Okay, look at the screens. Are they taller or wider? Because they're not perfect squares.
Wider.
They're wider, aren't they? These screens are a bit wider than they are tall. No matter what version you have of whatever calculator, they're never actually perfect squares. So when you graph a line like y equals 1x and a line like y equals negative 1x, although they're perpendicular on your calculator, they don't look that way because of the angle of the actual, because of the skewness of the actual screen. Let me show you real quick. So here's our axes. And y equals x is look like this. And y equals negative x looks like this. Okay? They're definitely perpendicular. They're absolutely perpendicular. But if you graph y equals x in y1 and y equals negative x in y2 on your calculator, they won't necessarily look perpendicular because everything is stretched. It's like those movies you see nowadays, which drives me insane, where it's like a widescreen film, and you put it on a widescreen TV, and then the film itself is widescreen. So by the time you're actually watching the movie, yeah, the TV is like this big, but you're actually only watching this much of the screen. It's like absurd. It doesn't make any sense, because everybody wants everything widescreen, so it looks like panoramic now. But if you were to have a TV that's widescreen, and then the film has these black strips on the top and bottom to make it widescreen, you get this like skewed version of the video. That's kind of what's happening in your calculators. Okay, it's really stretched out this way. So when you graph these two lines here, again, if you want to write the equations down, you can. This is y equals negative x, and this is y equals x. If you were to graph those two, yeah, they're perpendicular, but they don't look like it on the graphing calculator. Okay, they don't necessarily look like they're perpendicular there. Yeah. Anybody have an extra stylus for Tristan?
It's fine. I don't need it.
We're not going to take much notes after this. I mean, we're going to do an example. That's about it. And then I'll give you guys time to work on stuff. So here, this is the right angle I'm talking about right here. Okay, in case we're uncertain about what perpendicular means. Perpendicular means they meet at what angle? 90-degree angle. Okay, 90 degrees. 90 degrees is simply go like this with your hand. Okay, that's what 90 degrees is. The letter L. The letter L makes a 90-degree angle. The letter T, the letter I, all those letters. Okay. So if we look at statement 2, statement 1 is obvious. Let me draw another line actually, just for the sake of it. I'm going to draw another line in green. Oops, that was ugly. Hold on. It's very difficult for me to draw parallel lines, so just bear with me. It's just difficult in general to draw parallel lines by hand. Okay, those two lines are parallel to one another. Let's say the one in green, its equation is y equals x plus 5. Okay? 5 is the y-intercept, that's right here. The slope of this line is 1. The slope of this line is 1, and its y-intercept is 0, so you don't have anything here at the end. But the lines in green and blue are parallel to one another. Okay, the lines in green and blue are parallel to one another. The line in red is perpendicular to both of these lines, it turns out. There's a right angle between there, and there's also another right angle right here. Perpendicularity between not only the red and blue line, but the red and green line also. Again, the reasoning is that the product of the slopes is -1. Look at the slopes. This slope is -1 times this slope, which is 1. The product of -1 times 1 is -1. That's what this statement is saying. But this is really annoying to use as a reason. See this right here, what I just circled? This is really annoying to remember. So I don't remember that actually. I never did when I was a kid either. What I remembered is that they were negative reciprocals. Let's highlight that, please. They're negative reciprocals. And this is the statement I want you to remember that I've just highlighted in red. That the slope of one line is equal to -1 over the slope of the other line. -1 over the slope of the other line. For example, if the slope of a single line, let's draw our axes there. Let's say we've got this first line here, and let's say its slope is, I don't know, let's say it goes up 7 over 5. There's the slope of that line. I'm not giving you the equation, I'm just giving you the slope, okay? So let's say the slope of that line drawn is 7/5. If I want to find its perpendicular line, or a line perpendicular to it going through any point, I don't care what the other line's y-intercept is right now, but I just want another line drawn, and I want to draw that line perpendicular. I would go ahead, draw a perpendicular line in. If I want to draw that, again, it can go anywhere. There's a perpendicular line. So the red line is perpendicular to that blue line there. What's the slope of that blue line as a result? What is a negative reciprocal of 7/5? What's the negative reciprocal of 7/5?
Negative 7 over 5.
Not -7 over 5. Hannah?
Negative 5 over 7.
-5 over 7. Remember, it's negative reciprocal. You got to flip it and switch the sign. So whenever, here's a simple rule. When I used to teach this, I taught in DC for a while. A couple of my students used to always say, switch it and flip it, switch it and flip it. It just means switch the sign and flip the fraction. Whenever you want a line perpendicular to another, switch the sign, flip the fraction. Switch it and flip it, switch it and flip it. Okay, if you can't remember that later on, but it's the negative reciprocal. Negative means take if it was positive, make it negative. Reciprocal means switch or flip the top and bottom. If the original one had a negative slope, the new one has a positive slope, obviously, because that's the converse of that statement. All right, do we get the concept first, then we can get into examples? So again, lines that are parallel, same slope. Lines that are perpendicular, negative reciprocal slopes. Let's go right into an example. Let P be the point, 2, negative 6, and L the line, 3x minus 4y equals 8. Find an equation in standard form of the line L1 through P and parallel to line L. Find an equation of another line L2 through P and perpendicular to the line L. So you need to utilize the information that's presented to you. If two lines are parallel, what do we say again about their slopes? If two lines are parallel, what do we know about their slopes, Kate? The slopes are equal to one another. So for part A, since this line is going to be parallel to the original, what is the slope going to be for part A? Remember, the line that we're going to draw in a moment is going to be parallel to this one right here. It's parallel to what's boxed in. What's the slope of the line that's boxed in? Bridge?
3.
What do you got?
3.
Not 3. It's in standard form, Bridge. It's not in slope-intercept form. Max? Close. Max said negative 3/4.
Oh,
3/4. Good. It's negative A over B, right? Remember, in standard form, it's not, you're looking at that as if it's slope-intercept, right? You can only do that if it's y equals. It's not y equals, it's 4y. So here, remember, slope is negative A over B, which in this case would give me negative 3 over B, which is negative 4, or simply 3/4. So I know that part A is going to have a slope of 3/4 because part A's line is going to be parallel to the line we started with. The goal is to find a line parallel to the one we started with. What else do we know? What else do we know about this line? That's the slope of the line. What else? We need something else. Slope is not enough to give me an equation of a line, ever. I need something else. Hannah?
It needs to go through the point to negative 6.
Yeah, it's got to go through the point P, which is 2 comma negative 6. Again, read what it says in part A. Find the equation of a line in standard form L1 through P and parallel to L. So to be parallel to L, that's where the slope comes into play, m equals 3/4. If it's going through the point P, then 2 negative 6 needs to satisfy the equation because it goes through that point. So as a result, for part A, you've got a point, you've got a slope. Either you can go right into standard form, if you'd like to, which works, or you can use point slope. It does not matter. Because this is asking for it in standard form, it might be useful to go right to standard form. But if you're not really comfortable doing that yet, use point slope and then solve and make it standard form. Okay, I'll do both methods for this for part A. So for point slope, what would it look like? If I were using point slope and applying this point and this slope, putting it into point slope, what would it look like? What would I get? Very good. Point slope. Just tell me what point slope is to start at least. You ready? Point slope memorized? What is it?
Yeah, y equals
That's slope intercept.
Oh, no. Wait. Oh, yes, no. Y minus y1 equals m times x minus x.
Very good. So there's we start with point slope. We'll take both approaches, okay? So the point slope approach, and then a little bit later we'll take the standard form approach. You need to know these forms, okay? You need to know all three of them. So for point slope, what do I physically do? For point slope, the name indicates the direction in which you should go. Max? And then plug in the? Yeah. Plug in the point and plug in the slope. So the points you're going to plug in is, again, 2 for x, that goes in right here, for x1. Negative 6 for y, that goes in for y1. The slope is 3/4. That's what happens when you plug in a point slope. Obviously, y minus -6 is really y plus 6. Okay, you should recognize that right away, obviously. Notice what I'm doing. If the problem, let me give you a little input here. If the problem said slope intercept, you could either gone to slope intercept, which is y equals mx plus b, and solved, or you could distribute the the 3/4 now, right? You could distribute the 3/4 and then move the 6 over to get it into y equals mx plus b form. But it's asking for standard form, not slope intercept form. Because it's asking for standard form, I don't need to distribute the 3/4. I actually want to get rid of the 3/4, or I want to get rid of that 4. I want to get rid of that 4, so what should I do to get rid of the 4? Ash? Yeah, multiply both sides by 4 to start. In doing so, it looks like this. The 4 times the quantity y plus 6 becomes 4y plus 24. When this 4 gets distributed to both of these, right? Is that clear? The common mistake, though, that I pointed out last class was this, though. This 4 does not get distributed to these two, because this 4 and this 4, what do? They cancel each other out. So here and here cancel. So those 4s are going to cancel, leaving behind 3 times the quantity x minus 2. We can go further. I'm going to move well, it doesn't matter at this rate. I'm going to move, I don't really care. I'm going to move the 6 over to make this a 30 by adding 6. And I'm going to move the 4y over by subtracting it. And there's my answer. Okay, I'm going to add 6. I'm going to move the 4y over by subtracting it.
I got a 4y plus 3x equals -30. Is that okay too?
Nope, you made a mistake. If you're going to do that, it should be 4y minus 3x. Look at your work. Do you see why?
Yes.
Are you sure?
Yes.
Okay, but that would be all right. Now, traditionally, Tristan, the book gives the answers with a positive coefficient for x. I don't give a hoot. It doesn't matter. It really doesn't make a difference whether x has a positive coefficient or not. So if you give an answer of 4y minus 3x equals -30, that's the equivalent of this. Yep, it's fine. I saw another hand pop up. No? That's it? Just doing that again? Messing with me? All right. Well, we'll continue. Let's keep going. So that's point slope turned into standard. Let's go right to standard form. Well, if it's in standard form, remember that -a over b is the slope. So if our slope was 3/4, we could call either a or b negative. It doesn't matter in this case. So if I know that, again, I know the slope. Let's scroll up so you can see it. It's above right there, okay? I know the slope is going to be is going to be 3/4 rather, sorry. So this 3 and this 4 can go in place automatically here. Okay, because this is going to be 3/4, I can say to myself, all right, well, this is really equal to -a over b, right? Take a look up here, please. This -a over b is where this comes from. So I could say that a is just -3, and I could say b is 4. Again, if I want to take the slope and go right to standard, I could set a equal to -3 by just looking at this and saying, well, if this is -3, it's going to be -3, which is 3, and make b equal to 4. So make this a 4 if you'd like, and make this a -3. You can already see the answer coming through. I mean, look at the connection here, please. This is so obvious. This and this, look at the connection. Very similar already. Now, the last part that we have to do for these is solve for c, right? We need to know what c is. When we're looking for capital C, or when we're looking for b as the y-intercept, when we do y equals mx plus b, what do? What do we do to determine c? We have to do something still. What is that command, or what is that step that we have to take? Yeah? Plug in what? Yeah, we have to plug in the coordinate that's on the line, because this coordinate satisfies the equation always. So if this satisfies the equation, we can plug it in here and solve for c. So plugging in 2 and -6 Okay, plug in 2 and negative 6, please. As a result, giving you negative 6 plus negative 24 equals negative what? 30. Okay, so C is going to be negative 30. And Tristan, didn't you say a moment ago that you got an answer of 4y minus 3x equals negative 30? Well, that's exactly what we have here. Okay, so take a look. Take this line right here and rewrite this line at the bottom, please. This exact line right here, we write it at the bottom. But instead of putting a C in, put negative 30 now. And there's your answer. These are absolutely identical to one another. Look at them carefully and see how they're identical. All I've done is multiplied everything by negative 1. Okay, look at that. 30 becomes negative 30. 3x becomes negative 3x. Negative 4y becomes positive 4y. These are the exact same equations. They're absolutely identical. Okay, again, this is the same exact answer as this. All I've done is multiplied everything in here by negative 1. Making that negative 30, making this negative 3, making this negative 4 into positive 4 over here. Okay? So this was part A. Part A asked for a line that was parallel to the other line. What is the difference between A and B? What does part B ask us for? What does it say? Just read it. What does part B ask for? It doesn't say a line parallel. Yeah, perpendicular. So look at the setup, please. All I want you to do is look at the setup. The line is still going to go through the point P. So 2, negative 6 we're still going to use, right? You see that? We're still going to use this point. But what's the slope going to be now for the line perpendicular? This was the line parallel. What is the slope perpendicular to this? George? Negative 4 over 3. Switch it and flip it. Switch it and flip it. Switch it and flip it. So again, switch the sign to make this negative and flip it. So for part B, we're going to use a slope that is negative 4/3 because the other line's slope was 3/4. And this is the negative reciprocal. So we now are guaranteed a line perpendicular. We also are going to use the point 2, negative 6.
Would C be 30?
Well, that's the question we have to figure out now. The question is, determine the equation of the new line. So see what we just did? We chose 2 methods, right? Pick either of those methods, whichever you prefer, and do it again. It's not going to be negative 30 for C. Okay? I'll tell you that. You're going to try something else for this one. So on your own, please, choose either method. Either choose point slope or standard form. I don't care. Either one is fine. But now use a new slope. That's all that's changing. Remember, the point hasn't changed, but the slope has changed now. So use a new slope of negative 4/3 and the same point of 2, negative 6. Either use point slope or standard form. Either one of those is fine. Try it on your own. See what you get. Please remember on the right-hand side when you're doing this that the 3 cancels. That's the most common mistake I see a lot of. Okay, assuming you're doing point slope, sorry. If you're doing point slope, those 3's cancel on the right. Here's what I got at the bottom. 4x plus 3y equals negative 10. Okay, check your work, please. Go through the process. I used point slope. If you used point slope and you made a mistake, look at mine and see what you did differently. If you use standard form, try to identify your mistake along the way. If I did standard form, and I can do that real quick on the right-hand side, standard form would tell me the following. I would say, well, the slope is negative 4/3, which is equal to negative a over b. So I could say that a is 4 and b is 3 already. So if I'm using standard form instead on the side, it would be this. And look at the answer, guys. 4x plus 3y equals negative 10, right? Look at my starting line. 4x plus 3y equals c. Now all you got to do is find c. So it's going to be the same answer, obviously. We're going to apply that point. Four times 2 is 8. 3 times negative 6 is negative 18. C equals negative 10. So again, the exact same answer either way we do it. The key here is, yeah, George, go ahead.
You said it's fine if, like, if you want the opposite, like, I have 10 equals negative 4x minus 3y.
Yeah, same thing, yep. Again, I'm telling you that when you check in the back of your book, they traditionally make x positive always, the coefficient. See what I'm saying? So they would multiply that answer by negative 1. So it's not incorrect, though. You understand what I mean?
Yeah.
It's the way it's given. But look, again, the key here is this, two things. This is the common mistake right here. When you want to get rid of this fraction, multiply by 3, these cancel, but this 3 gets distributed. A lot of students distribute to this area, which you're not supposed to do, because these 3's cancel, and the negative 4 itself gets distributed, right? Over here, the common mistake is figuring out what goes in for A and B. So all I want you to do ever is this. Write it out like this, literally. Look at this. Negative 4 takes the place of negative A, so A must be 4. 3 takes the place of B, so B must be 3. Once you made the statements that A is 4 and B is 3, this next line, 4x plus 3y equals C, is very easy to come up with. But it's coming up with A and B first, then applying the point to come up with C. Let's do this one more time just to really emphasize this. And let's do it in slope-intercept form. For the perpendicular one in slope-intercept, please. So the same setup, negative 4/3 to negative 6. So the exact same slope and point to go through, but I want you to start with slope-intercept and only use that. And give an answer in slope-intercept. Okay, plug in what you know for your slope. You'll have an equation, and then you could determine B by applying the point. Remember, plug in your slope first, and then apply the point to solve for little b. Now apply the point for y. Negative 6. X is 2. So this step here is applying the slope. All right, you're plugging it in. This step here, is applying the point, and then solve for b. Okay, it makes life easier to get rid of fractions if you can anywhere. So if you want to start by multiplying everything by 3, that's fine. If it just makes life easier on you, if you prefer to. Okay, if I multiply everything by 3, 3 times negative 6 is negative 18. This is another common mistake right here. 3 times b is 3b, isn't it? But then 4 times 2 over 3, what happens to these 3's? These 3's cancel, leaving negative 4 times 2, which is negative 8. Okay, again, look at these 3's here, please. They cancel, but this 3 still gets distributed to this part because there's a plus sign. So this distributes to both of these. 1, 2. These cancel, this 3 carries down. And then solve for b. You're going to add 8, giving you negative 10 equals 3b. And then divide by 3. B is negative 10/3. So my answer will be the following. Okay, again, how do I get this answer? I go from this line, which is really pretty much my answer without the b, right? This line right here that I'm touching, that I'm pointing to, this is the answer without the b value. So take this exact thing and rewrite it down here. But once you solve for b, take this value of b, whatever you got, plug it in here for b, so that your answer actually makes sense. And what I'd like you to do is to recognize that this is the same exact thing as what we had up here and here. Solve either of these up top for y equals. Look, how would you do it? You would subtract 4x, right? Which would make that negative 4x, and then divide by 3. You'd have negative 4/3 x. You would have the negative 10. That would have to be divided by 3. Oh, there it is, negative 10/3. So if you solve either this right here or this right here, solve either of these for y. Either of these solved for y gives you this. Okay, but the reason or the way I had you do it was by applying it to slope-intercept form right here. Okay, you see how they're all the same answers? And what I'm going to do at this point, I was going to have you guys do that like round-robin group thing where you help each other with stuff, but I'm realizing that I'd rather actually focus on working with several of you individually. So what I want you to do is this. I want you to... How much time do we have? What time is this period? Anyone know? Is it 55? Or 8? Or 49. 49. You have only 9 minutes, sorry. Try to get a head start. Take a look at what the homework is giving you. Tomorrow your problem sets are due, not the homework. But just look at the homework now for the next 8 minutes. I'm not saying you do all the problems. What I'm saying is this. Look through the homework. See if there's any problems that you're like, I have no idea how to do this. So that in the next 8 or 9 minutes when we have time, I can come by and work with you individually. If you think you're confident, you're good so far, you want to just jump right into the problem set or do a little more work, that's fine also. Okay? Alright. Yeah, I'll be in my room after school, for sure. I'll be in 403 after school, so you can come by. When's the homework due? The day of the test, right? I told you? So the problem set will be due tomorrow, the homework will be due on Wednesday, and then the project is due on Thursday. Am I right with these timelines? Yeah. Keep track of those things. Problem set tomorrow, homework Wednesday, project Thursday. Okay, the project you got to be keeping in the back of your mind. That's got to be close to done at this point. You should already, all of you got raw data. It's more of just finishing all, right? Coming up with all of your scales, giving weights to each part. If you're really struggling with the project still, you should come today after school. You should not wait any longer. I'll be in my room. If you have project questions, definitely come by. Test is Wednesday. Tomorrow's a C day, so it's going to be a short review period. It's a math schedule. You have math during the day. Tomorrow we have it's All Saints Day, right? Tomorrow's All Saints Day. So tomorrow's schedule is like it's a couple periods, then we have mass, and then a couple periods after mass. So it's like 32-minute periods instead of 45 minutes. But you have mass for like an hour and a half. You have mass. And how would it say they're actually doing a job?
Yeah.
Did you do that? Is that it?
I don't mind mass. I like mass. But to me as a teacher, I prefer having 45 minutes. Yeah. 30.
Yeah.
Definitely mass. Try practicing for these. I don't see how many other.
Just write it on.
You're writing your plan? Good. So you're doing homework right now? How many problems? Did you check the odds? Odds are all correct? Yeah. Alright.
Yeah, I finished my project.
Guys can do those points, you can do slope or whatever. And then you recognize this is defined or the equation. Yeah, that's tricky, right? As soon as you see the export, it's the same, you know, the equation stays. Here, good, slope,
Wait, so are you ready for the first day?
points. Those points you use this one here. That's your plus.
Okay, you know what?
This is y minus
I still can't tell if you're serious.
y minus -1 and -1 is how
So
many?
confusing.
Y minus x is actually opposite, so just check that, see that works. I'm going to give you your second problem set grade. I'll call you up so you can see what the grade was for it. I will definitely get those put up in your drive folder, or so I'll tell Natalie at some point today if she can do that. I'll actually email her right
If we had
now.
a hard copy, we already did.
If you had a hard copy, I gave it back to you already, yeah. So you should have it in your notebook somewhere.
Project is due Thursday.
Yep. What's that? Oh, you're asking me. Luke, come on up. Luke, then George, then Hannah. So it was out of 20 your last problem set. 14.25 out of 20. Check it out on the calculator if you need. 13.75 out of 20. 18.75 out of 20. Bridge. Ash. Max. Bridge, Ash first. Ash, 19.5 out of 20. Bridge. This is your last problem set, Bridge. 13.25 out of 20. Max, 20 out of 20. Kate, Tristan, Annette, Yeehaw. Annette, 18 out of 20. Tristan, 13.75 out of 20. Kate, 20 out of 20. Yeehaw, 18.75 out of 20. Again, these are problem set number 2. I will definitely have them in your Dropbox today, okay? I'll make sure Natalie puts them in there if they're not there already. Which they're not, you guys said, right? In your Drive folder. I'm going to pull that up right now and see why it's not in there, because I thought I saw them in there. So I'm going to go in your Google Drive folder and delete chapters 1 and 2 textbooks. So I hope they're... If you didn't do it, I'm going to go through each and just delete them. Luke, you already did it? You got 2 and 3 loaded in iBooks?
Yeah.
Okay, I'm deleting chapter 2. It's still in there. Yes. You have a question about the project? Yeah, come on up real quick.
Confused right now. Like I already have a scale, and I just don't know now. Like, why is this weight necessary? Like, why do we need?
Because the scale is not alone enough to give you an overall view. Like, what's most important to you out of all these things? Honestly, which would be most important?
Like now it's academics.
Academics? Yeah. So in your case, you would rate that the highest weight. You would give that like an 85 or a 90. See how those are higher weighted?
Yeah.
The ones that don't really matter, like maybe you don't care about the location. And this person clearly didn't. They gave it a 20. So this weighting is another way of giving weighted perspectives to each category. So if one category means more to you, it should have a higher weighting, right? So eventually you give it a weighting out of 100, you calculate the weight as a decimal, you take 85 and divide it by the total sum, 585, to get a decimal, then you multiply that decimal by the decimal you gave it earlier, to get a new decimal actually.
Oh, I see. So like, even if it's not good, like...
Even if it's not good, but it doesn't matter to you, then it really wouldn't be important, yeah, in the end. So that's how much does it matter to you individually. Okay? Practice that today and maybe come by and show me afterwards so I can see that it's right before you turn it in, okay? Guys, you can always check your projects with me before you turn it in. So as you go through the process, some of you are doing this already, just send me emails and stuff. Ash, did you open the textbook in iBooks yet? Oh, you were in the bathroom, I think, when I said it. Could you make sure she opens an iBooks and deletes it out of Drive? For the project, it has to be positive. Oh, yeah, the coefficient of x. In your text, preferably, they write them as positive, yes. But, again, does that make sense? Okay? All right, guys. You're welcome, guys. Have a good day, guys. I'll see you after school. If you need help, come on by. I'll be in 403.